Hello, good evening to all of you, and welcome to the week 12 or the last session of the problem solving session, which has been conducting for the course named Earthquake Geology, a tool for seismic hazard assessment, whose course instructor is Professor Javed N. Malik, Department of Earth Sciences, IIT Kanpur, and here I am, Anjali Dikshit, PhD scholar in the Department of Earth Sciences, IIT Kanpur. So, in this week we will mainly discuss about the waves, and more specifically the ocean waves, and how, like, what are the parameters that you should know about these waves, and also we will see the classification of the ocean land features, for example the backshore, offshore region. So let's start this session. So for this problem solving session, the first problem I have taken is identify the correct coastal ocean bathymetry in ascending order from coastal land to ocean. So for this question we have 4 options, like foreshore, backshore, nearshore and offshore, and the combination of all these 4 terms. So to identify the correct sequence of all these shore, let's understand from this figure. So in this illustration you can see, like, if I start from the coastal side, which is on the right hand side, or I am marking like here. So this is the coastal line which is represented here, and if we move towards the left hand side direction, you can see that the region which is from the coastal line to the high tidal shoreline, we called it as a backshore. And if we move forward, then the region from the high tidal shoreline to the low tidal shoreline, which is present over here, is called as a foreshore. And if we again move forward and continue our path, so the next region that we got is the near shores, where you will find breaks. And what are these breaks? We will see in the subsequent slides. But for now, just remember that here you will mostly encounter breaks where the ocean waves discontinue their motion. So these are the breaks, and if we continue our path towards the left direction, we got the offshore. So if we talk about the sequence starting from the coast, and here we have this region, we have a ocean. So if we continue our path, so we can see that first we encounter backshore, then we have a foreshore, then the near shore, and the last one is the offshore, or the deepest part, which comes here. You also can see that here is the continental slope, and this the whole other shore that we have discussed, for example near shore, foreshore and backshore, all are coming on the continental shelf area. So this is how you can demarcate them in terms of continental plane. So the 4 shores are coming on the continental. This complete area is called as a continental shelf, and then this sloping area is called as a continental, C for continental, and then slope area. So this is how their depth is also increasing with respect to their movement. So to answer, and apart from that, there are also other kind of land features that you can see on the ocean side. For example, a wave cut feature, or the cliff kind of features, or the notch features. And another important aspect about this beach terraces. Now the question comes like how these beach terraces form and how it looks like. So this greener area that I have marked earlier is, we can call it as a beach terraces, because here you can't see any encroachment of the sea water. Okay. And another important thing about this ocean terraces, that its elevation or its sequence can be vary as per the sea level changes. For example, if you have a high sea level, and this high sea level, in what scenario you can get? Can anybody comment on it? Like what, in what kind of situation or the condition you will get the higher sea level, or the period, like glacial period or the interglacial period? Yes. So during first let me do this thing. Okay. Yeah. So during interglacial period, you will get the higher sea level, and in that kind of scenario, your coastal line will get reduced, and it can be happen that the ocean water come up to this touch this coastal line. But in the glacial scenario, where your sea level will get reduced, then in this area where you currently are seeing the beach or the beach sand, it can also act as a ocean terraces or beach terraces, where this all area will grow up as a green landmass, or you can find vegetation over here. So then you can see that you will find a terraces kind of, or the stairways kind of feature along the ocean. So you may get two terraces and then beach sand, and then this ocean will continue. So all these phenomena are related to the sea level changes, and this is how the coastal line, you can see the variation on the coastal line as per the sea level changes. And there is also another good kind of marker, we can say, that through which we can map the sea level changes, is a coral reef, and how the coral reef help into achieving this kind of, or marking the sea level changes, we will see in this session only. So now, having idea about the sequence, now we can, I think, answer the question. So what should be the order? We have to mark from the coastal to the ocean area. So can you suggest me what would be the appropriate answer? It's B number, because first we see the back shore, then the foreshore, then the near shore, and the deepest shore is the offshore, which comes after the continental shelf. Sorry, not continental shelf, continental slope. Now moving to the second question, which I think it's an interesting one, is as a wave approaches the shore, the wavelength dash and wave height dash. So here, as we till now we have understood that in ocean we encounter waves, but how it react when it approaches to the shore, it's a very interesting phenomena, because like whenever you go to the beaches, you must have seen that how the waves come at the beach. If you see on the deeper ocean, it will act differently, and if they come at the beach, it behave differently. Now why there is a difference in the behavior is a crucial thing to know. So to understand this change in behavior, first let's understand why do these waves form. So these waves form on the ocean or the lake when there is a energy transferred between the wind and the water. So wind has a higher energy, so when this wind transfer its energy to the water, this is how waves formed in the water. So the main cause or the driving force of these waves to be formed on the ocean is due to the wind. And since ocean has a larger surface area, like it's a very wider plane, So larger the area and if the stronger the wind, then there are highly likely chance that the larger waves will form in the ocean, and that's why you can now you can conceptualize that on the lake you have not very or you not find very high energetic waves, but in the ocean you do find, because there a wind has a larger get the larger area through which they can transfer their energy to the ocean water. So now, having idea about how these waves form, let's understand their components, which I think very basic thing, but yes, just to brush up the concepts, let's understand this. So majorly we have a three components if we talk about any kind of wave, and for ocean wave also we have these three major components. So first is the wavelength, then amplitude, and the third one is the wave velocity. So just to give you a recap, so what we call a wavelength, wavelength is a distance from the crust to crust or trough to trough. So here this whole length would be the wavelength. And if I talk about the amplitude, so amplitude is the vertical distance between the crust and the trough. So this vertical distance would be my amplitude, and the wave velocity is the velocity. So if wave is moving in this direction, and since wave is a velocity is a vector, so the direction of that vector would be in that direction only where the wave is moving. Let's understand now its motion. So generally what kind of motion we encounter is the orbital wave motion, and so along the wave the water itself moves up and down, but only moves a small amount in the direction of the wave motion. So here definitely wave will like along the wave water will move, and it causes a point on the water surface describe a circle with a diameter that is equal to the wave amplitude. Now to understand it with more clarity, let me show you. Okay, I'm sorry, I thought it would work, but since I have converted, okay, since it's a PDF, so I am unable to start this clip, but yeah, you can definitely see this clip on the, this is available in the Wikipedia. If you'll type the wind wave, you will find this GIF clip and you can play it. So there you will find that the topmost point that is on the surface will form some orbital kind of movement, and the radius of the circle will directly proportional to the amplitude of the wave. And this phenomena is not restricted up to the surface of the water, it transfer to the deeper depth as well, but it has a limitation or has a depth of penetration. And what is this depth of penetration, we will see in the next question. So for now just understand that it has, the wave has a orbital motion where the topmost point has the highest orbital motion or the highest energy, but when it goes deeper and deeper, the magnitude of that energy or the motion will diminish, will start diminishing. Okay, so if you are at this point, you might see that this point is not moving at all because energy got diminished while reaching up to this point. And if we talk about in terms of radius, so suppose it has a radius of 20 meter, then the below one might get the radius of, or the orbital motion radius of could be 15 meter, and this point could have a radius of 10 meters, and this is how it diminishes with respect to depth. Okay, so to answer this, I think okay, there's a change in sequence, but don't worry. So yes, now we have to come over here. So as I was talking about that at some depth this energy will get completely vanished. So now what is that depth? It's equal to 1/2 of the wavelength. Okay, so suppose the wave has a wavelength of 200 meter, which is a general like as per the wind energy, this is this wavelength is a very common wavelength if we talk about the ocean scenario. So that the depth would be it's 100 meters. So up to 100 meters it is a general depth through which the water can experience the energy, and below that depth the water will be just static, there will be no movement. So if we talk about a few key points, that the motion on the surface is also transmitted to the depth, that we have already seen. The water disturbed by a wave to a depth approximately 1/2 of the wavelength. So this information is very important. Remember that it goes up to only 1/2 of the wavelength, and this depth is known as a wave base. So this is called a, so if we'll in this figure if I talk about, so this entire line if I draw, which is at the depth of half of the wavelength, would be treated as a wave base. Okay. So now we have understood this is how wave propagates. Its effect is not only on the surface, but its effect also can be present at the depth as well. Now imagine a scenario, this entire wave is moving. Okay, so definitely this the lower point will also get moved. So now how it looks like, let's see. So now we all know that our shore is not, or the sea bottom is not a simple flat line, it has a transition. Like if we talk about from the continent, it slopes like this and this. So this is how its its shape or its landform gets changed. So if we come to the ocean continental part or the beach part, so you will see that there is a continuous decrease in the depth of the seabed or the continental plane. So suppose here you are getting your 1/2 wavelength, and till here you are experiencing the vibration or the energy, below that you are not experiencing anything. This situation is normal situation, but if this wave continues to move here or up to this beach, now what happens with time, this depth will got disturbed. Why it got disturbed? Because it will start feeling the resistance or the dragging because of this this surface. What it could lead to? It could lead to that the wave energy will get decreased, and due to which the wave amplitude will increase and the wavelength will decrease. And at some point of time when it will encounter a breaker, this wave, now see here it is following, when we are in a deeper region it is following a sinusoidal path. Okay, but if it encounter to a depth where this energy is very much depreciated and it will encounter a breaker, its shape is suddenly got changed, and this is the way you see the wave on the beach side. And this is a very common feature we have all seen, like those who go to the beaches. So now due to this, what happens, that the wave amplitude or wave height increases and the wavelength decreases. So there are two factors which cause these kind of change. Is first there is a flattened and there is a slow dragging due to this change in the continental slope, or the change in the depth of the sea bottom or the continental bottom, if we see. I hope it's clear. If not, you can ask a question right away. Okay, clear. So, since we were dealing with first, we were dealing with the second question, which is that as a wave approaches the shore, the wavelength dash. So, wavelength, what happens to the wavelength? Yeah, correct. Yeah. So, since the wavelength is decreases, why wavelength is decreases? Because there is a change in the pattern of the continental slope. Okay. Now, since the now wave is not able to complete its whole path, because now it's getting a breaker over here, or it's not able to go to the complete. It's not able to complete its whole cycle. So that's why it's encounter a break due to this slope, and that's how its wavelength decreased. Now since wavelength is decreased, so what? So to compensate that decrease in wavelength, the wave height will get increased. So they are inversely proportional. Always remember that wavelength is inversely proportional to the wave height. And there is another way to look this or to validate this relation is like when you are in the deep ocean, you will not see a very high wave. The height is very nominal, but the wavelength, if you will see, like in the next time if you go to the beaches, try to observe this thing, that when the wave is in the deeper part of the ocean, you will not see much of height, but you will see a longer path it travels. So this is how there is a inverse relation between the wavelength and the wave height. So there is another question which is in the same concept as I mentioned just now, that if we talk about the deep ocean tsunami waves that are dash height and dash wavelength. So tell me what could be the correct combination. Now we are talking about the deep ocean. Yeah. So you are B number, right? So you are saying A number. Why A number? Because waves are of low height. Yes, correct. Okay. So moving ahead. So this is the last question of this session, and after that, if you have any other question, we can discuss about it. So this question says that corals are good indicator of sea level change. When an island uplifted during an earthquake, the upper part of corals dash, but the lower part, that is still under low tide level, dash. So have you heard about the corals and how they are important? If yes, yeah, then okay. So they are mainly as the question says, that these are the good indicator of the sea level changes. Now tell me, like, what will happen when this when there is a upliftment? Any wild guess or any guess you would like to make? If the corals will come out, right? So what will happen if they come out or when they exposed to the surface? Correct, they will die because they need some like appropriate condition in which they can blossom, or then in which they can grow. But on the surface, that is not the habitual condition for them to grow. So that's why whenever they come to the surface, they will die. But the part which is still under the water, they will grow in that part. Now how they will help us to to do the dating part, or to know that when the sea level change or happened, or whether the upliftment has exactly happened or not, because these are the indicators which are very helpful for a geologist or the geophysicist to validate the marker or validate the event, if some kind of this event has happened in the past or not. So in that scenario, coral act as a very important marker. So this is the example that I have taken, that is I think a part of your course slide as well. So this is the example from the south of Tokyo, where let's focus on this sample, this particular first sample. Here you are seeing that two white patches, one is over here and they are falling on the same line, and there is another observation that we can see is this patch, this again a white patch, which is above on these two event or these two patches. Now what they did the dating. So from the dating, what it got to know that this lower patch has an age of around 1923, which correlated with the an earthquake happened in 1923. But what interesting phenomena that they got to know, that the above patches or the upper assemblage has a higher age. Now in a geological sense, if we talk about, we every time if we talk about the geochronological order, you always have a older rock lying below the younger rock. This is the natural sequence, but here the sequence got disrupted. So how it could happen? It could happen if there is a sudden tectonic event, because if it is happened due to the sea level change, then it should have a gradual progression or gradual sequence. It should follow, but it hasn't followed the gradual sequence. Now we got the anomaly that a older sample is at the upper depth and the younger sample is at the lower depth. So this kind of drastic change could only happen due to the tectonic event. So this is how they came to know that in 1703 a tectonic event has happened due to this older coral sample come at the top. So this is how they are very useful to do the dating and to validate the earthquake event or the tectonic event, or even the marking the sea level changes as well. So if I read about this whole event in a very sequential manner, so the lower coral sample is of younger age, and this lower assemblage emerged during the 1923 Taishio Kanto earthquake, which has a magnitude around 7.9, but upper sample is of the older age. That is the very triggering thing. Now due to the uplift of the upper samplage is most likely correlated to the 1703 Genroko Kanto earthquake, which has a magnitude of around 8.3. So yeah, this is how we use coral as a markers to map the geological events. So if this we have to answer this question, definitely you mentioned it correctly earlier only. So the answer would be that the part that is on the that come on the surface due to the upliftment will definitely die, because they will not find their habitual condition to grow, but the part of the coral that is still in the water and at the suitable condition, they will continue to grow laterally, because coral we know that coral grow laterally on the sea or the ocean. So this D would be the correct option for this question. Now, if you have any question related to this wave encroachment to the shore or the coral part, you can ask, or even in general, because this is the last session that we are having for this particular course. So, if you have any question related to the course, you can ask right away, or otherwise we can close the session. So, I think if everything is clear to all, then we can close this session, and I wish you all the best for your exams that is coming next or next to next week. So, yeah, all the best, and I hope you will do all well, and will next time we'll see you during the next uh, session of this course. Yeah, thank you.